talk about the lawnmower problem. We call it the lawnmower problem because this kind of looks like an old style push mower. What's a lawnmower problem? Instead of the ramp being at an angle, did I say angle? The ground is at an angle, but the ground is level, but the force is at an angle. And it's still the same punchline components. Here, instead of parallel and perpendicular, I'm probably going to go back to horizontal and vertical because now the ground is the way we're used to seeing it. But you could continue to label things parallel and perpendicular if you want to. I'm going to choose to use good old X and Y. So what's the lawnmower problem? Where we have vertical force components other than the normal force and mg. Or, hey, where the ground is still horizontal, but there's a force at an angle. Did I say angle? In a problem like this, the key mistake kids make, they want to let the normal force equal mg. No. Oh, and if we're on a ramp and there's forces at angles, the normal force is not equal to mg cos. I don't think I'm going to do one like that with you, but it's an extension. I like example 1, I like example 1, I like example 1. Example 1 is the next question. Here's a good lawnmower question. It says, find the normal force, friction, and acceleration. Gotta be honest, I might just say find A, but your spoiler alert is you're gonna need to find these to get there. Mason, any thoughts on how I might want to start out? I'm gonna do a free body diagram. Did they give me a picture? I'm gonna label the picture, but I'm gonna label, let's visualize what's going on. First of all, it looks like someone is pushing down at an angle. This thing is partly getting pushed into the ground. I don't think the normal force is going to be mg. Do you think the normal force, from what you've learned in physics, is going to be bigger or smaller than mg? It's going to be bigger because it has to overcome the person pushing. Let's remember that. All right. Mason, what are the forces acting on this? Get the obvious one. I totally agree with you. One mass, so just mg. What else? Normally, I would say normal force is next, but much like when we were on a ramp, we tried to deal with the angle as soon as possible. We're going to deal with the angle next. So I have this 200. This 200 is an F applied, but it's being pushed down at an angle. Mason, did I say angle? Components. What are the best components? I'm going to zoom way in. I'm going to break this into vertical and horizontal components, like that. Color, color, color. You okay with that, kiddo? What else? Are we sinking into the ground like quicksand? Or are we flying into there like Superman? By the way, there should not be any white space here. I've told you these were typed in Word 95 for Mac, and I may redo all these diagrams, but I'm kind of hoping that I retire before I absolutely need to, because that's going to be a fat ton of work. So, what would you say? Sorry, Mason, what's next? Okay, how big is the normal force? If I'm going to be really technical, the same size as those two combined, because the normal force page is canceling out mg and the vertical component. So I'll kind of eyeball that, but I might exaggerate it just so it catches my eye. The normal force is going to be about like that. What else? Is there friction in this question? Which way? I think pushing down and to the right will cause this to slide to the right. Now, it might not. If we were pushing at a really steep angle, like on my chair, I am pushing towards George, but because I'm pushing down so strongly, friction is so big, it's pushing this way. I'm probably not going to give you one that complicated. So let's assume friction is pointing to the left. I might feel comfy like as a nasty question in the homework, but well, test. Okay. What else? I think I got F applied right there. Right? I started to think, don't I have to put F applied? No, it's there. Okay. I think I got everything. So, A says, find the normal force. Well, Are we sinking into the ground like quicksand or flying like Superman? Really what that means is everything down has to equal everything. Everything down, it looks like it's Fy plus mg. That has to equal everything up. I need to figure out Fy. I'm going to draw a bigger triangle here. You can if you want to, because I'm going to be doing some trig. So here's Fy. Here's 200, F applied. You know what? I'll label it F applied with no numbers just so that I can be generic. Fx. Color, 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 color. So I know F applied. I'll label that with an H. Fy, opposite or adjacent. Which trig function? Are you telling me that Fy is sine? That will work. However, if you choose to go parallel and perpendicular here, the two lines, stupid trick, won't work here. And this is why I switch back to X and Y when we're on flat level ground, because it is horizontal and vertical. Okay? Because this would be parallel, and parallel two lines in this case is going to be, of course it is. So I think this ends up being 200 sine theta plus mg equals Fn. 200 sine 20 plus 50 times 9.8. And I get 558.40. I'm going to write 558, but I'm going to store this on my calculator or carry some extra sig figs as necessary. Cool. Nicholas, what does B want me to find? Friction. Oh! Friction is what times what? I don't know that. Yes, I do. 558 point blah, blah, blah. Oh, okay. 0.1 times 550. Let's try that again, Mr. Duke. 558.04. Nick, put your calculator down. You're multiplying by 0.1 in your head without a calculator. Obviously, the answer is 55.8, right? And you had that without your calculator, right? You were not going to type this into your calculator, were you? but what? That 55.84. Yep. I'll multiply by 1 on my calculator on a test. Like I'm that paranoid of making silly mistakes, right? Always. Okay. Owen, what C you want me to find? Who's winning? Do you see it? I'll give you a hint. Not that 200. What? FX. By the way, have you noticed once we find components, we never use the angled stuff again. We did that for kinematics, for projectiles. Same here. What's my equation going to be, Owen? Yep. Oh, and they want me to find the A, so divide by M. Okay. Fx. Oh. Do you know which trig function is Fx? Of course you do. A is going to be 200 cos theta minus All right, Nick, I guess I owe you a bit of an apology because I'm going to write 55.8, but I absolutely would have wanted to use my answer button there, so I might have typed it in anyhow. Divided by, oh, and what was the mass? I've scrolled down. Sorry? 50? So it's going to be bracket 200 cos 20 minus answer button divided by 50. I don't have any built-in error check here. It is possible for A to be bigger than 9.8. Unlikely, but there's nothing preventing that from happening if you were pushing really hard. 2.64? Okay. That's a lawnmower question. We're going to do one more. Well, you can either be pushing down at an angle, or you can be pulling up at an angle. Like example 2. A force of 18 newtons is applied at a 21 angle to the mass below. Find the acceleration. Okay. Knock, knock. Free bod. Yeah, very good. Free body diagram. Okay. So, fine, Brea. What are the four? Get the obvious one. Good. And now let's pause and deal with the angle. This time, components, I think my component is going to go like this. There's Fx. There's Fy. I could have followed the dotted line. I wanted my triangle to be a little larger, so I actually dropped down a tiny bit and did Fx. I guess to make my triangle larger, I also could have just cleverly zoomed in on the screen. Thank you, Captain Obvious. Sorry. I didn't grow up digital, okay? Brea, is there friction in this question? Which way? Probably to the left. What if I wasn't sure? I could quickly calculate Fx, calculate friction, and just do a comparison. It wouldn't be quick, really, for either of those. I'd have to do some physics, but I could find out. But let's make the assumption friction. Oh, which one did we miss? Is the normal force here going to be bigger, smaller, or the same size as mg? Ah, so I'll really exaggerate it. Thunk! There's normal force, so it catches my eye. And I said find the acceleration. I didn't walk you through all the part A, part B, part C. By the way, what if this wasn't accelerating? What if it was at rest? What two forces would have to be the same size? Fx and? Okay, that would be a nice little twist on this. The person is pulling and it doesn't move. Okay, Fx has got to be the same size as friction. That might be helpful. Anyways, Brea, what's my equation? Who's winning? I couldn't hear, sorry? Who's winning? Yes. Who's the loser? Aiden, did you see it? I said, who's the loser? And she looked at you. Oh, Brea, that's cold. That's cold. Man. Last day I got his name wrong. Now today you're making fun of him? Boy, the world is just against him right now. Fine. Who's the losing force? Friction? Right? There's my tug of war. Are there any other forces along that particular horizontal stretch? Then what does winner minus loser always equal? Okay? And again, you can see if we weren't moving, A would be 0. Then you could plus friction over and you get Fx equals Fr, like Kai said. But in this case, in fact, Brea, I'd go like this, right? Because they asked me to find A. I would also have no problem giving you the acceleration and asking you to find mu, get the mu by itself. I would consider that a fairly advanced question because it's some yucky algebra, because for a lawnmower question, all the stuff you're used to is tweaked slightly. In fact, let's keep going. Fx. If F applied is along the hypotenuse there, the angle, did I say angle? Fx, well, hypotenuse, adjacent, opposite. Which trig function is Fx, do you think? Which trig function is Fy? So does that help you figure out which trig function is Fx? Of course it does. So this is going to end up becoming F applied cos theta minus mu, and I'm going to just write the normal force because this is going to be complicated. That equals A. Usually I do this next step off in the margin somewhere. I'd like to find an expression for the normal force. I might try doing this expression in my head on my homework, but are we sinking into the ground like quick? Are we flying like Superman? What's my vertical equation then? Well, everything down has to equal everything. Everything down looks like it's mg has to equal everything up. That looks like it's the normal force and Fy. How would I get the normal force by itself? Is it a swappy dance?
No, just minus it.
Just minus Fy. So I think the normal force is going to be mg minus Fy, FYI. And so that's going to go right there. Okay. So I end up with A equaling F applied cos theta minus mu bracket mg minus Fy. And that whole thing has to be in brackets because it's mu times the entire normal force all over m. Oh, FYI. On a test, I would rewrite this meticulously and carefully. Is this a test? Brea, I'm going to be lazy and just go F app sine theta. Now let's plug in numbers, because this is complicated enough. I don't think I would go running off to my calculator without writing out the numbers. What was F applied? Was it 18? Cos, what was theta? 21 minus, what's mu? I don't know what's mu. What's mu? 0.23 in brackets m times 9.8. Take away 18 sine 21 degrees. Close off that bracket. All over 7. This one is complicated enough. I would strongly urge all of you, try typing this one in. What was your question? Isn't it F applied in the question? I think it says.
Oh.
Does it? Yes, I hope. This is my way of saying I usually steal diagrams and reuse them and just change the numbers without labeling them because I was in a rush. This has got some teeth. Okay, open up a bracket. 18 cos 21. I got to close off the cos. Minus 0.23. Open up another bracket. 7 times 9.8 minus 18 sine 21. Close off the sine. Close off the mini bracket. Close off the top. Divided by 7. I think I got all my brackets balanced. Whew. Yeah, looks good. Y'all get 0.359? Yeah? 9? Yeah? Barely accelerating at all. Now, if you didn't get that, don't clear your calculator. I'll come look at it in just a second because we're essentially almost done the lesson. But 0.359 meters per second squared. Whew. And you know what else I'll do? I'll go like this, Mr. Dewick. There. That way when people are looking at the notes, they can see how I typed this in. Ah, I love being able to do that. That's so handy. Sorry? I'll put this as a PDF on the website, yep. Okay. What's your homework? A couple lawnmower questions. First of all, technically every question from there is fair game. 1 is good, 2 is good. In a normal year, I would give number 3 because here, the ground is at an angle. Did I say components? That force is in the same direction as mg perpendicular and normal force. So it's actually not too bad, but I'm going to cut corners. I don't want to overwhelm you. Same with number 4 is really, really cool. Which way will which direction will it move? I'm going to skip that. I've skipped a bunch right now. So far I've assigned 1 and 2. 7 is upper level, but fair game, I think. 11 is good. I know, numbers are jumping around. There is no 10. That's because I add and delete questions and I'm too lazy to renumber things. Bear with me as I ponder here. I'm going to say 15, so I skipped 12, 13, 14, and 16. You might be able to do your work right on this-ish. You might need to do it on a separate piece of paper. It's really up to you. But we are finito, done, the unit.